All right, this is AP, AB, and BC Calculus. We're doing Unit 5, Section 2, which is the extreme value theorem, global versus local extrema, and critical points. So there's a bunch we're going to cover today, but I want to address a note at the bottom first. So at this point in your education, you can't use pronouns to describe functions. So you can't say it, right? I mean, I guess you also could weirdly gender your functions, but that would be bizarre, right? So like we don't usually call a function she or he or they, right? So but you definitely can't call a function it, right? So moving forward, we're going to be dealing with a lot of f of x and f prime of x, and sometimes f double prime of x, or an f of x and a g of x, or also an h of x. You're going to have a lot of functions in these problems, so you can't use the word it in an explanation. You always have to clearly say f of x such and such, or f prime of x is 0, or h of x is positive, right? You have to clearly state which function you're talking about. And I'm going to remind you about this in a lot of videos, but it's going to be pretty important because when you're justifying your answers to things, the number of times that I see the word it to clearly, to describe something that I need explained explicitly, but you kind of vaguely say it's going to be an issue, and that's true for everybody, so we're going to make sure we address it. So let's do a little bit of vocab first. So minimum, the plural of minimum is minima, because it's Latin. Although technically, even though it's awful, the dictionary also accepts minimums, but it bothers me aggressively. So this is a noun in this usage. It can also be used as an adjective, such as in meaning like minimum value, right? So f of c is a minimum if in the open interval surrounding c, like immediately around c, f of c is smaller than all of the other f of x. So just to show you what I mean there, let's look at an example. So here's an example of a min. See how in the open interval surrounding this point, this is the lowest point around. Notice it has to be surrounding that point because if you were allowed to only pick points to the left or right of a value, then the value could easily always be a max or a min. So see how this is the lowest point in the open interval around it, right? So f of c would be a minimum. And you can say the same thing's true here. Like if you looked at this open interval right here and say, okay, well on this window around c, this is definitely the lowest value, that's a minimum. And you can see that you can have graphs that have lots of minima, right? So here, if you look at an open interval, this is clearly the lowest point, right? Lowest point, lowest point. That's a min, right? So minimum, 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 or minima, plural. Okay, so a maximum is the same thing, but it's the highest point around. So a maximum, and again, you can, here we're using it as a noun, but you can also use an adjective like maximum value. I missed a quote there. The plural of maximum should be maxima, although you can say maximums because the dictionary is accepting of all terrible grammar. So f of c is a maximum if in the open interval around c, f of c is bigger than all of the other f of x. So if you notice here, if we look at like this open interval, right? So let's just call this c1, right? See how in this open interval, all of those values are physically lower than f of c, right? Or f of c sub 1. So you can see that those are max values, right? Extremum, the plural of extremum is extrema, but not extremums because the other two plurals should also be wrong, but English is sad. So extremum is essentially a word that refers to either a maximum or a minimum. It's a more generic term. So you'll see extremum or extrema often when a math test is trying to not give away the answer about whether something is a max or a min. So in order to get around that, math teachers or math tests or whatever can just generically use the word extrema to encapsulate all max and min values, right? Okay, so extreme value theorem. If f of x is continuous on the closed interval from a to b, then f of x has at least one maximum and one minimum value on a b somewhere. Okay, so what does this mean? And this is the EVT, the extreme value theorem. It means that if you don't lift your pen up, because that's the continuous part, while drawing from A to B, then at some point, there has to be a highest and lowest value in that window. So I drew some of the samples, including the one that tends to throw people off. So I drew, we'll talk about absolute, global and absolute versus relative and local in a minute, but essentially, so I did in red, I did the absolute values, meaning the highest and lowest around. So see how on AB there are actually two minimum values, right? But this one's called the absolute min, meaning it is the lowest on the entire interval. That's the one guaranteed by the extreme value theorem. The lowest value on the entire interval is at A. up here is the highest value. See how there is a max and a min in red, both of them, on every interval. There's also another min here, but that's called relative because it's lower than all the points around it, but it's not the lowest point ever. Here we have a line, and sure enough, on the window from A to B, there is a max, there is a min. They happen to be the two endpoints. Here we have a nice curve. There is a highest value, there is a lowest value, and there are two other relative max and min values that are also the highest and lowest immediately around them, but they're not the highest and lowest ever. Then you have this weird version that's kind of a it's meant to be a version that kind of takes people aback and confuses them a little. If you have a constant function, every single point on this interval is both the max and the min. So let's just pretend for a sec that this is the number 5. Every point on this interval is 5. So what's the highest number on this interval? 5. What's the lowest number on this interval? 5. The number 5 is the max and min for this entire interval, and it's the only value that the function attains, which is a bit of a weird example, but just to show you. All right, so F extrema, meaning maxes and mins, can only occur at the following x values. Included endpoints, meaning, so see, we can see that in this picture if we go back a second, right? Included endpoints, see how that's that included endpoint, that closed dot is a min, that closed dot is also a min. Here we have a closed dot that's a max and a min. Included endpoints mean that there are brackets and you actually have a closed dot at the end of the interval. So included endpoints or critical numbers, which are x values for which the derivative of the function, f prime of x, is either 0 or does not exist. However, not every endpoint or critical point is an extremum, and we're going to talk about that in 5.3. We're not just there yet. So, just to show you some examples of what I mean by that, right? So, let's look at this y equals f of x, right? So, see how when you have a horizontal tangent line, which is when f prime of a is 0, right, there is an extremum there. In this case, it is what we'd call a relative max. And we will go into relative versus absolute. We're just not quite there yet. And then if you follow this function, here's another horizontal tangent line, and you'll see that f prime of b is 0. That's a horizontal tangent line, and that is a relative min, right? Here, I have y equals g of x. There is a minimum at the included endpoint. Then the graph comes up, and it's continuous, but it's got this pointy, cuspy thing, right? It's got a sharp edge. So g prime of that b doesn't exist, and sure enough, that's a max, right? So this is a max, this is a min, right? Just like this was a max, and this was a min, right? Now here, at this spot, h of x, right, our h prime of a is 0. This is a horizontal tangent line. H prime of a is 0. But this is what we call a saddle, right? So a saddle is where a function is going uphill, levels out, and then continues to go uphill. It doesn't have like a hill or a valley, right? So maxima are often hills, right? They look like hills. Minima are often valleys. So this is called a saddle. You'll see them a lot. They're essentially what an x cubed looks like. And then this value right here, well, this would be a max. Now this graph actually doesn't have a minimum because both directions go down forever. There's no min on that graph, but we're going to talk about more of that moving forward. So, given the x value, give the x value of all critical numbers of f of x. If f of x has included endpoints, identify them as well. So remember, what it means to be a critical number for f is that f prime of x is 0, f prime of x does not exist, right? That's what it means to be a critical number. And then if you have included endpoints, you also have to list them, which here we do, right? So here we have included endpoints at x is negative 10 and 0. So I have included endpoints at negative 10 and 0, and then I need to find where f prime is 0 or f prime doesn't exist. So let's go ahead and find f prime of x. F prime of x is going to be 3x squared plus 10x plus 3. I want to know when f prime of x is 0. Well, that's going to be when 0 equals 3x and x. I need a 10 there, so this will be a plus 3 and a plus 1. Yep, FOIL to check in your head. So I get that x is negative 1/3 or x is negative 3. All right. And f prime does not exist is never going to happen because it's a polynomial, right? So essentially, for something to not exist, you have to have a situation where there's a denominator most of the time. And so that's not going to happen. So my only values that I'm supposed to give you are the included endpoints. So these are my answer, right? Together, these are my answer, the included endpoints and the critical numbers. All right, you go ahead and try P1, right? So you're going to find the critical numbers, and if there are included endpoints, you're going to list them, right? So I'm just going to go ahead and list the included endpoints now. right? So the included endpoints are x is -2 and 5, and we're going to learn why that's valuable moving forward. When I go to find my critical numbers, I need to find when f prime of x is 0 or does not exist. So I differentiate f, and I want when either f prime is 0 or when f prime does not exist. So does not exist is going to be never because it's a polynomial and polynomials always exist. So that's a never. This is going to be, if I set this equal to 0, I'll yank out a 4x squared and be left with an x minus 3. So either 4x squared is 0, which is going to give me x is 0, or x minus 3 is 0, which is going to give me x is 3. Both of those fall in this window of the included endpoints. So those are my 4 answers, right? Critical numbers have to fall in the endpoints that you're given, but you'll notice in the last one too that both of these fell in this window from -10 to 0. All right. Give the x value of any critical numbers. If there are included endpoints, list them as well. So critical numbers, right, are going to be when f prime is 0 or when f prime does not exist. There are no included endpoints in this problem. Right, so there's no included endpoints in this problem. There aren't any domain restrictions either because this is a cube root and cube roots don't have domain restrictions. So I go ahead and find f prime of x. Now remember that this is actually an x squared minus 4 to the 1/3. So I'm going to get that this is 1/3 x squared minus 4 to the -2. I said third and wrote squared. To the -2/3, right, times the derivative of the inside, which will be a 2x. So I get that this looks like this. Cube root of this thing squared. Yeah, okay. So now I have a situation where my f prime can be 0 or not exist, because for f prime of x to equal 0, when you have a fraction, that means the top equals 0. That's how fractions work. So f prime equals 0 when x equals 0. But f prime does not exist when the denominator equals 0. So that's going to be when the cube root of this thing is 0. And I think some of you could probably jump ahead and recognize that it's really only the x squared minus 4 that I care about, because as I put powers on 0, they go away. So I get that this is x plus 2, x minus 2. I get that my two answers are a -2 and a 2. So these are my critical numbers. Okay, so I have 3 critical numbers for this function. Now, again, right now I'm not telling you what we do with those critical numbers, except to say that extrema, if they occur occur at critical numbers. So it's important for us to be able to find critical numbers. So you go ahead and try and find P2. Again, there are no included endpoints, so we don't have to worry about that. So my f prime of x is going to be 2/3 x plus 3 to the -1/3 times the derivative of the inside, which is a 1. So I'm going to get that this is a 2 on top of a 3 cube root of x plus 3, right? So if I want to know when f prime is equal to 0, well, that's going to be never, because the numerator would have to be equal to 0, and that's a lie, so that doesn't happen. But f prime not existing, well, that would be when the denominator equals 0, which is essentially, if you divide by 3, you get that the cube roots of stuff equals 0, and then you cube it, and you just get that x plus 3 is 0. So the only critical number in this problem is x equals -3. All right, give the x value of the critical numbers. If f has included endpoints, identify them as well. Okay, so there are included endpoints, right? So the endpoints are x equals 0 and 2 pi. Right? So I've got the included endpoints already. When I go to differentiate, it's a lot easier if you rewrite this as the sine of x quantity cubed. So my f prime of x is going to be 3 sine of x quantity squared times the derivative of sine, which is cosine. So I want when f prime is 0 or when f prime does not exist. Well, this is going to be never, because again, there's no denominator, right? If this was like a secant or a tangent or something that has a value in the bottom, then we would be able to find a spot when f prime doesn't exist. So f prime equals 0 when either 3 equals 0 or sine squared is 0 or cosine is 0. So 0 equals 3 is a lie. 0 equals sine squared of x is going to mean that 0 is sine. Well, that happens at all the pi's, right? So we'll answer that in a sec. And 0 equals cosine, well, that's going to happen at the pi over 2's, right? Because that's where the y on the unit circle is 0. So I end up getting that in the window from 0 to 2 pi inclusive, I get 0 and pi and also 2 pi. And I get pi over 2 and 3 pi over 2. So my answer will be, I already have 0 and 2 pi up there, right? So it would be 0 and 2 pi and pi. I don't know why I put these in a terrible order. Let me fix it. That's going to bother me aggressively. If we were putting these in order, it would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, the 0 and 2 pi were already included in the endpoints, but that's, so essentially they're important numbers for two different reasons. All right, so you can go ahead and try P3. Pause me if you want. I would start by saying, hey, look, there are included endpoints. They are 0 and pi. Right, so check. I did that first thing. My critical numbers, I need to find f prime of x. Well, that's the derivative of cosine, which is negative sine of the stuff, times the derivative of the stuff, right? So I'm going to get that f prime of x is a negative 2 sine of 2x. And there's a couple different ways to do this. If you wanted to use the trig ID that sine of 2 theta is 2 sine theta cosine theta, you certainly don't have to. You could also rewrite this as a negative 4 sine x cosine x, and that's fine. Like either of these are, oops, sorry, didn't mean to scribble. Either of these are two totally acceptable answers. Either way, so in either case, there's no denominator, so it doesn't matter which of these you use. F prime of could be 0, but f prime does not exist is going to be never. Right? And the reason I'm making you write it down, even if it doesn't happen to be an issue in this problem, is sooner or later you're going to miss a critical number because you forgot to do the f prime doesn't exist. F prime doesn't exist won't matter until it does. And so you should always make sure you do the mental check that it's there and see that it's not an issue before you move on. So whichever way you pick, my guess, I would probably pick this, to be honest. I'd pick the negative 4 sine x cosine x. But my guess is that most of you wouldn't think of using this trig identity and you would do this instead. That's fine. If you do this instead, you want to know when 0 equals negative 2 sine of 2x, which is when 0 equals the sine of 2x. Well, remember, sine is the y on the unit circle. So we're saying, where is sine 0? Well, it's here and here. The problem is that because of this 2 on the inside, because this 2, you want to go twice around the interval. Now, the interval was originally just 0 to pi. So I'm going to pick 0, and I'm going to pick pi, but I'm going to go twice around the interval. So I'm going to pick 2 pi, right, as well, because I want to go twice as far. So twice as far around the interval. And the reason I'm doing that is because when I solve, I'm not saying that x equals 0 and pi. I'm saying 2x equals 0 and pi and 2 pi. I went twice as far around. So when I divide everybody by 2, I'm going to get that my answers are x equals 0, pi over 2, and pi, all of which fall in the interval. So those are my critical numbers. 2 of them already happened up here because they were endpoints, right? Cool. Moving on to the next one. All right, same thing, critical numbers, if there are endpoints, identify them. So there are no included endpoints, right? So I'm just going to go ahead and find my critical numbers. Remember that when you hear critical numbers or critical values or critical points, it's always asking you for the same thing. F prime is 0 or F prime doesn't exist. Remember, that's if you want the critical numbers of F. If I wanted the critical numbers of H, it would be H prime is 0 or doesn't exist. If I wanted the critical numbers of F prime, I would be using F double prime, right? You use the derivative of the function. So f prime of x is going to be u. dv is going to be e to the stuff times the derivative of the stuff plus v du. So I'm going to get that this is an e to the 2x times 2x plus 1. I want when f prime is 0 or does not exist. Well, f prime of x is 0 either when 0 equals e to the 2x, which is never, because e to the 2x is a positive number. That's a positive number. 0 can't be positive. Or when 0 equals 2x plus 1, which is going to give me x is negative 1/2. So that's definitely true. And f prime does not exist is never going to happen because there's no denominator. For something to not exist, you basically are setting the denominator equal to 0, and there isn't one. So your only answer is this negative 1/2. All right, same idea. You give it a try. Again, there are no included endpoints. Here's my u, here's my v. My f prime of x is going to be u. dv is going to be e to the stuff times the derivative of the stuff plus v du is going to be a 2x. So I think I can factor out an e to the negative x, and also I'm going to take out a negative x. So I'm going to take out negative x, e to the negative x. What's left is an x minus 2. So again, you'll see you're in a situation where there's no denominator. So f prime is 0 either when negative x is 0, which is at x equals 0, or when e to the negative x is 0, which is a lie, because e to the stuff, whether the stuff is negative or positive, e to the stuff comes out positive, or x minus 2 is 0, which will be x equals 2. And f prime does not exist is not an issue because there's no denominator, right? So, so my two answers, so my answer ends up being x equals 0 and 2. And again, we're going to spend a lot of time finding critical numbers and eventually making sign charts with them. All right, same idea. If they're included endpoints, give them. So here are my included endpoints. So I need to make sure I include 0 and 2 pi. The other stuff, the critical numbers, I need to find f prime. So my f prime is going to be u. dv is going to be a negative sine of x plus v. du is just going to be e to the x. So if I take out an e to the x, I seem to be left with negative sine x plus cosine x. Right? Notice that none of this stuff has a denominator, so I can find when f prime is 0, either e to the x is 0, which is a lie because e to the x is positive, or negative sine x plus cosine x is 0. Well, that means that cosine x is equal to sine x, meaning the x on the unit circle is equal to the y on the unit circle. Well, that only happens here at root 2 over 2, root 2 over 2, and here where both of the root 2 over 2's are negative. So my answer is going to be x is pi over 4 and 5 pi over 4. And then the last one is f prime not existing, but that's also not an issue because, again, there's no denominator. In order to have something not exist, it's pretty much set the denominator equal to 0. So my answer ends up being these two endpoints and also pi over 4 and 5 pi over 4. So this is my answer. All right. You can give the same thing a try. A word of caution, a secant does have a denominator. So suddenly there is going to be an issue. So included endpoints, I do have them. I have negative pi over 3 and pi over 3. Right? When I go to find f prime, I need a product rule. So f prime of x is going to be u dv, which is secant tangent, plus v, which is secant, du, which is just going to be e to the x. So I'm going to yank out a secant x and an e to the x. Oh, I don't like that order. Sorry, I'm going to fix it. I'm going to yank out the e to the x first. It just looks nicer. So e to the x, secant x, and then in here I'm going to have a tangent x plus 1, right? So f prime equals 0 is going to happen either when e to the x is 0, which is not possible, or when secant x is 0, which is also a lie, because if you picture a secant graphs look like this. See how they're always above and below the axis? So that's never 0, right? Secant starts up here at 1 and goes up, and starts down here at negative 1 and goes down. It's never 0, so that's a lie, okay? Or when tangent x plus 1 equals 0, which is going to be when tangent x is negative 1, and that does happen. That happens at the pi over 4s in quadrant 1 and quadrant 4. Sorry, quadrant 2 and quadrant 4. But remember that my range is from negative pi over 3 to pi, my window rather, not range, because that would be y values. My domain that I'm allowed to pick is this window. So this answer right here is going to be negative pi over 4. So that's the answer. So it's not a 7 pi over 4, which is where it is. It's coterminal with the 7 pi over 4, but 7 pi over 4 would not be in this interval. And then I do have to worry about when f prime doesn't exist, because if you think about it this way, both secant, right? So secant is a 1 over cosine, right? And tangent is a sine over cosine. So basically, they don't exist anywhere that cosine would not exist. So f prime does not exist anywhere that anywhere that cosine would be 0. So anywhere on the x on the unit circle would be 0. Well, that's only here and here, which is not in the interval, right? Because this is the interval I'm looking at. So this is okay in the interval that I was given, right? So my only answers end up being the negative pi over 3, which is an endpoint, the pi over 3, and a negative pi over 4. Those end up being my answers, okay? All right. Give the x value of the critical numbers. Same thing. If there's endpoints included, list them. There are no included endpoints, so I just need to find f prime using the quotient rule, right? So low d high minus high d low. Draw the line, square the low. Right. So the numerator ends up being an x squared plus 1 minus a 2x squared. So I think I get a negative x squared plus 1 over this x squared plus 1 quantity squared. if I clean up my numerator a little bit, I'm going to rewrite this as a -1 times an x squared minus 1 because it's a difference of squares and it's nicer that way. So I'm going to rewrite this as a -1 times x plus 1 times x minus 1. On the bottom, I have a sum of squares. Sum of squares are not going to factor over the reals, and also they are always positive. So if we want to know when f prime is 0, that's going to be when the top is 0. So it's not when -1 is 0, that's a lie, but it could be when x plus 1 is 0, so -1 is my value, or when x minus 1 is 0, which would be x equals 1. So those are my two answers there. If I want where f prime does not exist, it's when the bottom is 0, but that's never going to happen. So this is a lie. You can solve it and realize that it's not going to happen. You'd get x squared plus 1 is 0. You get x squared equals -1. So x is plus or minus the square root of -1, which has no real solution, right? We're not using i's for this. We want real solutions, and there are no real solutions. The easier thing to spot is that a sum of squares is positive, right? And you can see this too if you picture the graph. Like if you look at the graph of y equals x squared plus 1, it doesn't have any zeros because it starts down here at a y value of 1 and goes up, right? So there's no zeros, right? So my only answers end up being x equals -1 and +1, and that's it. All right, last one for this video. Now I do have included endpoints, right? So I have x equals -10 and I have -4, right? Now I should check, there is a vertical asymptote here, right? There is a vertical asymptote when x plus 3 is 0, which is at x equals -3, but that's not in my window from -10 to -4, so I don't need to worry about it, okay? So I don't care about that. So my f prime of x is going to be low d high minus high d low, draw the line, square the low. Right? And again, notice that the only time the bottom is going to be undefined is the same spot that's a vertical asymptote, and it's not going to be an issue because it's not in the interval we were given. So this numerator ends up being a 4x squared plus a 12x minus a 2x squared, right? So I end up getting 2x squared plus 12x over this thing that could be 0 on the bottom but won't be because realistically it's not going to matter to me when it's 0 because it'll be outside of the interval I was given, right? So it's not that it can't be 0, it's just that it doesn't matter for us. So f prime is 0 when 2x times x plus 6 is 0, right? Which is going to either be when x is 0 or when x is -6. So those are those two answers. And f prime does not exist when x plus 3, quantity squared, is 0, which would be when x is -3. But this is not in the interval, right? So even though it's an important value, it's not going to be a critical number here because it's not in the window that I was given. But these two are both in the window that I was given. Sorry, shifted the whole thing over a little for a sec. So these are all in the window. Those are my critical numbers. All right, so that's sort of the gist of how critical numbers work. We're going to move on in the next video to talking about how to make sign charts using these critical numbers.